Hi everyone and welcome back to my channel. For those of you that are new here, my name is Ellie and I'm the founder of Code of the Future, and today we're going to be continuing with the Rust course where I'm teaching you all about Rust for beginners. Before we dive into the tutorial, make sure you give this video a big thumbs up and subscribe down below if you are new to the channel. But with that said, I'll put my glasses on and I'll move you onto the screen. So in the previous video we looked at structs, so we looked at basic structs in this Rust file here, and then we added a bit more complexity and created our own functions and methods using IMPL, so implementation, and created our own struct, some methods, some functions, recalled them, did some pretty cool coding. So if you haven't watched that video, I'd recommend watching it before watching this video, just because I'm going to mention structs in this video briefly, so I don't want you to be too confused. But if you know what a struct is, then awesome. We're going to go into tutorial 15. I'm just going to cross off our previous ones. We'll save that one. Okay, awesome. So today we are going to look at what are known as enums. Now the reason I said to check out the previous video on structs is because structs and enums are essentially the building blocks to Rust. So I'm just going to say that structs and enums are the building blocks for creating new types in Rust. Okay, so if you recall from the previous video, which I'll just find again after I crossed it off, we did this section here where we created our education data type, and here when we defined our function we wanted that function to return the education data type. So that's essentially what I'm saying here is structs and enums are the building blocks for creating new types. So yeah, new types in Rust, awesome. If you'll recall from what we did in structs, we can enumerate a list of variants. So what we did was we took college, our college for example, and then we had major or minor, and that formed our education. And enums allow you to do something very similar. So I'm just going to say, let's consider IP addresses. We can enumerate all the variants. There's only two. So IP addresses can either be a version 4 or a version 6. Now don't worry if you don't understand what that means. You don't need to understand anything to do with IP addresses. It's just giving an example. It's just like how we use college and major and minor in the previous video. So okay, let's create an enum for IP address kind. And in here we're literally just going to say, okay, a v4 and a v6. So we'll call this an enum for the IP address kind. It's as simple as that. Now in our main function, we'll remove hello world, we can create instances. So I'll put that in comments. So we can create instances for each of our variants. So these are our variants here. And we'll just say let 4 equal our IP address kind, because that's our enum. I'm going to make an instance of it. And we're just going to say v4. Simple as that. And again we can do the same for 6 and just say IP address kind v6. Cool, so that's how we create an instance. Remember we did the same thing with structs and we looked at how you can create an instance of a specific struct. So there we go, that's our instance of our enum IP address kind. Now variants are actually namespace under their identifier, which is this here, which is why we use the double colon, and that's just so we can recall this from IP address kind. Hopefully that makes sense. We're going to move on, so we could create a function that will take in our enum type, so either 4 or 6. And the reason we can do that, we can do this because they're both the same type. And that's because we've defined it in here, which is quite cool. So let's do that. Let's create a function, and we're just going to say fn root, and that's going to be where, like root, there we go, where the IP address is. So let's say, okay, well, our IP kind is our IP address kind, which is what we have up here. We know that already. And we're going to open up our function. So this is our function, and we can just input something in here. So that's how we create a function and pass through this specific type that we have defined here, IP address kind. Recall the colon here is telling you what type it is. So here we have IP address kind as our type, and this is our parameter that we're inputting into this function. So our enum can capture the IP address kind, but let's say we want the actual IP. This is where structs come in handy. So we're just going to do a struct, and we're going to say IP address. And in here we're going to say, okay, the kind of the IP, whether it's a v6 or a v4, we're going to just simply say IP address kind. And this is our enum. This is our enum, and I just realised I've commented the wrong way. Yep, so that's our enum there, and then we're just going to say the address is going to be a string value. So what we've done here is we've created a struct like we did in the previous video. Our kind, so this feature we have of our struct, the kind is going to be IP address kind, which is what we defined here as our enum, and then the address of the IP, the IP address, is just going to be some string. Now in main, we're going to create a new variable so that we can host our local IP address. So just here I'm going to say let localhost equal IP address, which is our struct here. And inside here we're going to pass the features that we need, so the parameters, so kind and address. So let's say our kind, again, is just going to be IP address kind, and is going to be a v4, which is similar to what we did here. So yeah, exactly what we did there. And then our address is, we're going to create a string. Now this is just essentially creating a string in this format. That's how we do it in Rust. If you didn't know that, then there we go, we know it now. That's how we define a string. And this is going to be the IP address. Okay, let me just check I've got my semicolons everywhere. And I believe I do. I'm just going to give this a quick cargo run just to check that everything, how we have missing address, what's going on here, missing field address. Let's have a look, and it's because I've put a semicolon there instead of a comma. Let's check. Okay, form, that should be from, not form. We'll cargo run again, and there we go. No errors, just a couple of warnings. Okay, so let's make a little comment and say here, the IP address struct allows us to group the version of the IP address with the actual address, which is kind of cool. We've incorporated an enum and a struct together. Now let's say we actually want to store some specific data inside our enum. How would you do that? What would you label this as? That should have a comma there. What would you put in here? And it's very, very simple. You just do a bracket and just say, yeah, that's going to be a string, and there we go, it's also going to be a string. And that's, I'll just pop a little comment in here. To store actual data inside your enum, you just write and whatever data you want inside. And again, as I briefly mentioned, you can change this. So instead of having a string like we have here, we could have 4 different bit integers. So again, let me just find where that went here. A v4 could be u8, u8, u8 and u8, and then that's just 4-bit integers. Yeah, so that's pretty cool. Now what I'll show you is, instead of doing all this, we can then just simply say, well, let localhost equal the IP address kind. So IP address kind, let's find that. That's here, our enum, IP address kind. And then inside that we want v4, which popped up if you saw v4. So we want v4, but instead of a string format, we want it in the format we've written up here. So 4 u8 bits. So 1, 2, 7, 0, 0, and 1. Okay. So I'm going to comment that out. That was the long-winded way. This is the short way. Now, something that I wanted to mention is just that enums can store a whole variety of different types. So I'm just going to say enum variants can store a wide variety of types. So what better way to show you that than to demonstrate it? So we'll define a new enum and we'll call it message. Inside here we'll have quit, and this is just going to be, a variant that stores no data. We're going to have move, and this is going to have a struct within itself. So X is going to be an I32 and Y is going to be an I32 as well. And this is just stores a anonymous struct. We're then going to have, right is going to be a string. And we're going to have a tuple, I guess. So change colour, and that's going to be an I32, I32, I32. Okay, so this here is, I guess, a single string, and this here is just 3 integers, I guess. So there we go. That's just an example of the fact that an enum can store so many different types. So here has no type. Here this is a struct. Here this is a string, similar to what we had there. And this here is 3 integers. I realise I said that was a tuple, but it's essentially not. It's just storing 3 different integers. I just got a bit carried away when I saw the brackets. Now you may be watching this video and still being a little bit confused about structs versus enums, and I just want to show you that you could actually have written this enum here in different structs. Now that would have taken a lot of time and effort, and for the sake of the time of the video I'm just going to copy it from this Rust programming language document, which I always link in the description of every one of my Rust tutorials. So let's just put the above could have been written as structs. The issue, so we'll just put, but the issue is that they are all of different types. So the benefit of an enum, and we'll just put that here, the benefit of an enum is that all variants are grouped under the same message type. Very handy, really. Now we can do exactly what we did previously and use the IMPL, so implementation, and I'm going to do that just below our struct IP address. Now I realise that this video, it's a little bit chaotic with moving code in different sections, but hopefully it's you're finding it okay to follow along. So we are going to just say we can also make methods and associated functions in enums, just like we did with structs. Okay, so IMPL, classic, we did that previously. We're going to create an implementation of message, and inside here we're going to create a function. So let's say this is going to be function 1, open bracket, curly brackets, and that's just the standard of how we create a function. Hopefully you'll remember that from my function video. And in here all we're going to do is just say, okay, well, print ln and just put code of the future. Cool. And there we go, that's our implementation of the message function, of the message, and we've created our own function inside. So this is, I'm just showing you this as an example. We can do just like we did previously, and just do the same as we did with structs, but in enums. And because I went into depth, into a lot of depth with that in the previous video, I'm not going to go into too much detail now. That's why I just wanted to show you this. Okay, now what I wanted to move on to is something known as the Option Enum, and I'm going to do what I did in my previous video and just create a new file, and we'll just copy what we had previously just so I can start a new file. And in here I'm just going to say Option Enum. Now I'm not forgetting we need the main function. Okay, so let's start here, and both of these folders will be will be on my GitHub. So lots of programming languages have null values. Hopefully you'll know what that is, but don't worry if not, we're going to go into it today, which represent a very useful concept. A value can either exist or it can be null, i.e. there is no value. So that's a bit of an overview of null values. Now I'm just going to say here, the problem is that the type system in Rust can't guarantee that if you use a value, it's not null. That if you use a value, it's not null. In Rust, there are no null values. So you may be thinking, well, what is there? You know, if we have no null values, then what do we use? In Rust, we use what is known as the Option Enum. So instead, we have the Option Enum, and it looks something a little bit like this. I'll just copy that. There. So this is the Option Enum. It has two variants: none, which stores no value, and some, which stores value. So say stores no value, and this here stores some value in here. Okay. Now let's say you have a value, and that value could potentially be null, or it could, you know, it may not exist, or it may exist. You can counteract that by wrapping it in the Option Enum, which is what I'm just going to show you now. So we're going to go to the main function, and I'm just going to create a bit more space down here. We're going to create just a random number, and that's going to be 10. So sum here, we're using this kind of notation here, sum. So let number, that's sum. Now let this boolean, and that's going to also equal sum true. Now let nothing, and this is going to be the data type of the Option Enum, which is what this is here, option. And inside here we want an I32. So what this does, this option I32, is it will either be none or some of an I32 bit. And we're just going to let that equal to none. Okay, so what I'll say here is, since we are passing the non-type, can't spell today, the non-type, we need to state, well, we need to annotate the type. Rust can't infer it. Okay. Similarly, we can assign it to a value. So let's say I guess something be option, and we'll do an I32 again, and there we go. We have 10. Now this can either be 10, or it can be nothing. If you recall the enum here, the Option Enum. Okay. And not forgetting our semicolons. Now let's just do a quick reminder of data types and the lovely complexity of data types and addition and things in Rust. Let's start by assigning a value, let's say x, and that's going to be an I32. I'm going to let it equal to 14. Now let's say sum is going to be x plus, well, let's do something, which is our sum 10 here. And I'll just print. Goodness me, I'm so terrible at my inputting today. So let's try print sum. And what do we think will happen when I run? Sure, we'll all be expecting an error. Indeed we do. No implementation for an I32 and option I32. So I'm sure you will have expected it. You know, we can't do this as they're not the same data type. Now I'll just comment that out because I don't want you to run it and come up with errors. So what do we do instead? We can use unwrap. So I'll show you. So we're going to say let the sum equal. Now I'm just going to continue letting x be a value. Let x plus. Now just for the sake of the video, I'm going to change this something to y. In fact, I'm going to change that to x, this to y, then that can be y as well. Okay, so we'll just do x plus y. It's a little bit the arithmetic is a little bit easier. So let x plus y dot unwrap, or 0. And this is specific for the option enum. And what this is doing is we have defined y. I've just realised that should be x, and that should be y. So we have y, which is 14, and then we're going to take our x value, which we've defined as an option enum, which is either nothing or 10. And what this will do is it will unwrap the sum thing, so the sum, and print that, and if not, it will return 0. Cool, so let's just put this unwraps the value under x, and if none is passed, then it will return 0. Awesome. Now there's a lot more we can look into with this null type and the option enum in Rust. It gets quite complicated, so I'm going to save it for a future video, but you know, this is pretty much all you need to know when you're starting out in Rust. Now the very final thing is I'm going to show you what is known as match expression. Okay, I'll say this as if we've already done it, but we'll just say we have defined an enum above called movement, which we haven't done yet, but I'm just going to do it above. So here we're going to have an enum and we're going to call it movement, and we're going to have our variants in here. We're going to have left, right, and we're going to have jump. Okay, so what this is let's imagine we're playing a game of Subway Surfers. If any of you have played that game, it's the first game that popped into my head that you can like swipe left, swipe right, or jump. I guess you can duck as well, but we'll just omit that for now. Yeah, a very simplified version of Subway Surfers. So we've defined an enum, we have our movement in here, so left, right, and jump. And we're going to create a function called move player. We're going to have move, the kind of the parameter we input here is going to be our movement enum. So it's going to take these values here, and in here we're just going to do perform the action depending on information. So we're going to use what is known as, what we wrote down here, the match expression, and I'll just put using the match expression. So we're going to say match m. Inside here we're going to have conditions, and it's going to exhaust every single possible condition there is. So we're going to take movement, we're going to say left, which is what we have here, so left. That is going to, if that happens, we're just going to print moving left. We can do the same for right. Right, and here we're moving right. And again, movement jump, we can say jumping. Okay, so this here is how we define the match expression. We have a certain condition and we're saying that if this happens, then we do this. And that's essentially what this forward arrow is here. So it exhausts every possible, I guess, condition that there would be. So now if we move to the main function and we go down to where we have our match expression section, we're just going to say let player 1 equal movement, let's say jump, it's going to jump, and then let player 2, if movement is going to go right, and then let player 3, they're going to go left. Now what we can do is we can call our function, so move player, and we can pass player 1. And again, we can move player and pass player 2. Finally, we can move player and pass player 3. Okay, so a few errors actually just popped up then, and just had to go off screen and sort them out. So the first thing here, this originally said move, and that's just not correct because we're matching M to this here, so that should just be M, and that's because we're using the match expression and these two things must match here. So that's the first thing. The next thing, this was all correct. I'm having a little bit of trouble. Previously I quite simply just omitted this part here and I just said option I32. For some reason Rust doesn't seem to like that, and yeah, so to overcome that we're just going to simply input that there, and that seemed to fix everything. We'll just keep, all this code will be on GitHub, so if your code isn't working when you run it, just check over with mine. But everything now should be running as it should, and I'm just going to run. I'm going to clear everything that happened here, and we're going to cargo run, and eventually show you that here it says jumping, moving right, moving left, and indeed that's what we have. We have made the match expression, and indeed we know exactly what each of our players are doing. So that has been quite a long video on enums. Enums and structs, as I've said, are very fundamental to Rust. They can be quite hard to get your head around. There are plenty of resources online, so make sure to check them out if you are still struggling. But that has been enums in Rust. So that was the video today. I hope you enjoyed it. If you did, then please give this video a big thumbs up. Subscribe down below if you aren't already subscribed to the channel. Comment if you fancy commenting. I also have a donation page and a Patreon set up for exclusive behind the scenes footage, if you fancy checking that out. But yeah, as I said, thank you so much for watching. I'll see you all in the next one.